Good morning, everyone.
Good morning, sir.
Good morning.
Okay, yesterday I discussed about the two variation of client server model. The first was the network computer, and the second was the thin clients. Okay. Next, I discuss about the fundamental models of distributed computing system, in which I discussed about the interaction model. About the interaction model. In the interaction model, I discussed that what are the factors that we take when we study that how do components interact with each other? What are the different factors that affect the performance of a medium, of a network? For example, communication performance is measured in the form of jitter, in the form of bandwidth, and in the form of latency. So these were the topics that I had covered yesterday. So today I will continue with the different fundamental models, the rest of the fundamental models, that is failure model and the security model. So in the failure model, as you can see, in a distributed system, both the processes and communication channels may fail. Means in a distributed computing system, we have processes, for example, the client server or peer-to-peer, and a communication channel, the medium on which we are sending the message. Both may fail. There are three categories of failures: omission failure, margin failure, indicator failure, and the time failure. So in the omission failure, it refers to cases where a process or communication channel fails to perform action that it is supposed to do. For example, if I am sending a message, okay, if there is a failure while sending a message, or if there is a failure when the message is being forwarded on the channel, or when the message is being received by the receiver, when these are the cases when there can be a failure in a process or the communication channel. So first type of omission failure is the process omission failure. In the process omission failure, the first is the process crash. The process crash means that the main omission failure of a process is to crash. That is, the process has halted and it will not execute anymore. Means any process has been halted. It will not execute. It has failed. It will not again start. So other process may or may not able to detect this state. This crash happens in an asynchronous system. I had discussed about asynchronous in the interaction model. In the asynchronous, we don't have any time limit. Anytime any message can reach the sender, the receiver. Anytime the receiver can send a response, or anytime the sender can send its message. So a process crash is detected via timeouts. Timeouts means that if I have put a time that at that in within a time limit, I should receive a response from the receiver. In our asynchronous or synchronous, we have time limits that in a particular time, within a time frame, I should get a response. If there is no response, it means that there is some failure. So in an asynchronous system, a timeout can only indicate that a process is not responding. It may have crashed or may be slow, or the message may not have received yet. Means in an asynchronous system, a timeout will mean that any process has crashed, yani the receiver has crashed, or the receiver is very slow because it has received many requests from clients, so it is taking time to process, or the message may not have reached the receiver. The second type is the process fail or stop. In this, a process halts and remains halted. Okay. Difference between process fail and stop and the process crash is that this process fail or stop happens in synchronous systems, whereas in the process crash it happens in asynchronous system. So in process fail or stop, other process may detect this state. Okay, this can be detected in synchronous systems when timeouts are used to detect when other processes fail to respond, and messages are guaranteed to be delivered within a known bounded time. Means in, as I discussed, in synchronous system we have time limits. We know when a sender is going to send his message, how much time will it take to reach its destination, and how much time the receiver will take to respond. So this fail or stop happens in synchronous system. So other process means a sender can know whether a receiver has crashed or failed or not. So these were the process failure. Now in the communication omission failure, we have the failure that happens during a communication, in a communication channel, in a medium, the medium in which we are sending. So there are three parts when sending a message. One is the sender, and with the sender we have an outgoing message buffer. So when a sender is sending a message, the message goes into its message buffer. The message buffer will forward the message that is received from the sender to the incoming message buffer that is attached with the receiver. There is an incoming message buffer which is attached with the receiver. So, incoming message buffer will send the received packets or received messages to the receiver. So, the first type, that is the send omission failure. What is send omission failure? It is the loss of message between the sending process and the outgoing message buffer. When there is a failure between the sender and the message buffer which is attached with it, that is called a send omission failure. Similarly, a receive omission failure means that there is a loss of message between the incoming message buffer and the receiving process. And in the channel omission failure, it is the loss of message between the outgoing buffer and the incoming buffer. So if we see the diagram, we have a sending failure, sending omission failure, when there is some failure between the sender and the outgoing message buffer. Okay, and there is a receive omission failure when there is a failure between the incoming message buffer and the receiver. And while in the communication omission failure, there is a failure in the communication channel itself. Means when there is a failure between the outgoing message buffer and the incoming message buffer. So the next type of failure model is the Byzantine or arbitrary failures. This Byzantine or arbitrary failure are very difficult to detect because Byzantine or arbitrary in the Byzantine or arbitrary failure, a receiver can give a wrong response due to some software or hardware failures. It can give some wrong response. So it is a very little difficult, but it can also be checked with the checksum. So here we see that a process continues to run but respond with a wrong value in response to an invocation. Means the process continues to run. The receiver will continue to run, but it will respond with a wrong value in response to invocation. It might also arbitrarily omit to reply. Means it may, if it receives many messages, it may be possible it may fail to reply. This kind of failure is hardest to detect. So a communication channel can also exhibit this kind of failure by delivering messages more than once, or deliver non-existing messages. It is possible that it may respond with corrupted messages, or it may deliver more than one messages, or it may deliver non-existing messages. For example, I'm going to a ATM and it may be possible due to some failure. The ATM is not able to respond, or it has given me more cash than it could that I had requested. So these are the Byzantine or arbitrary failures. So this kind of messages are rare because communication software use checksum to detect corrupted messages and use message sequence numbers to detect non-existing and duplicate messages. Thus, this kind of failure is masked either by hiding it or by converting it into more acceptable type of failures. For example, checksums are used to mask corrupted messages, effectively converting a Byzantine failure into an omission failure. Next type of failure is the timing failure. These are applicable only to synchronous distributed systems where time limits are set on process execution time, message delivery time, and clock drift rate. Any of these failures may result in responses being unavailable to clients within a specified time interval. Means this type of failure is only possible in synchronous distributed systems where we have a time limit. Means within a time a process should execute, within a time the message should be delivered, and we have a shift clock drift rate. Yani there's only a certain change in the clocks. So when there is a failure, any of this execution and any of the time then that is called a timing failure. Any of these failure may result in responses being unavailable to clients within a specified time interval. In asynchronous distributed system, no timing failure can be said to occur even if a slow server response causes a timeout, because no timing guarantees have been made. In our asynchronous distributed system, we do not have any fixed timing guarantee. Just as I did discussed, in a asynchronous, there is no time limit. So these are the different failure models that I have discussed, where we discussed about the fail or stop. It happens, it affects the process, in which the process will halt and remains halted. Other process may detect this state. Means this fail or stop happens in a synchronous systems. In a crash, the process halts and remains halted. Other process may not able to detect this state because this failure occurs in a asynchronous systems. Omission failure happens in a channel in which the message inserted in an outgoing message buffer never arrives at the other end. Incoming message buffer means while I'm sending a message, the message is not received by the receiver. Next is send omission. It affects the process in which a process completes a send, but this message is not put in its outgoing message buffer. It means that the sender has sent the message to the outgoing buffer, but due to some failure, the outgoing message buffer does not receive the message. Similarly, there is receive omission failure, which also affects a process. Here, a message is put into a process incoming message buffer, but that process does not receive it. Means it has been received by the receiver buffer, but the buffer could not forward the message to the receiver. Next, we have the arbitrary or Byzantine, which affects the process or channel, in which the process or channel exhibits arbitrary behavior. It may send or receive arbitrary message at arbitrary time, commit omissions. A process may stop or take an incorrect step. Means a receiver may send a incorrect response. So these were the different failure models. Now I will discuss about the security model. The security of a distributed system can be achieved by securing the process and the channel used for their interaction, and by protecting the objects, example web pages or databases, that they encapsulate against unauthorized access. Means in a system we have a database, a web pages. This should be secured from unauthorized access. So we have to secure the processes. The processes can be a hardware or software, and the channels, the medium through which we are sending a message, should be secured. So in a distributed computing system, we treat everything, every system, every process, every channel as an object. Every object means that that has some properties. A channel has a property, a system has a property, a sender has a property. receiver has some properties. So these are all of these are objects. Our mailbox is an object. So we should protect the objects. Some objects may hold a user's private data, such as their mailboxes, and other objects may hold shared data, such as web pages. Access rights are used to specify who is allowed to perform which kind of operations, that is, write, or execute on the object. Means everyone should have some right, access right. Every users should have some access right. For example, we have a right to open our mails. We have a right to compose our mails. So these are some rights which is given to everyone. Threats to processes like server or client processes include not being able to reliably determine the identity of the sender. If I'm not able to identify who has sent my message, then it can be a threat to me. Threats to communication channel include copying, altering, or injecting messages as they traverse the network and its routers. This prevents a threat to the privacy and integrity of the information. Means if there is a threat that someone is copying your messages, you're sending a message to your friend, but someone else is copying that message, or someone is altering that message, then it can be a threat. This presents to the threat and the privacy and integrity of information. Another form of attack is saving the copies of the message and to replay it at a later time, making it possible to reuse the message over and over again. That is, remove a sum from a bank account. If a attacker does some coding in which he is able to withdraw money from a bank account, someone else's bank account, then it can also be a threat. Encryption of messages and authentication using digital signature is used to defeat security threats. We have different types of digital signature to prevent some different type of attacks. So these were the different fundamental models in the distributed computing system, which I discussed. The three types are interaction model, the failure model, and the security model. Now, I'm going to discuss about the different problems that are faced by designers of distributed system. So, any question till now? किसके पास कोई क्वेश्चन है? अगर कोई क्वेश्चन है तो पूछ सकते हो अभी, और वी कैन कंटिन्यू. So first problem जो है that hello. So first problem is widely varying mode of use. Widely varying mode of use means that there is a variation in workloads. Yani many application have the requirement of more bandwidth compared to other application. YouTube needs more bandwidth compared to any text messages. For example, WhatsApp. In WhatsApp we send only messages, text messages, mainly text messages. But if it is handling videos, then it will require more bandwidth. So there is a very widely varying mode of use. The system components are subject to wide variation in workload. Example, some web pages have millions of hits a day and some may not have any hits. There are some web pages that no visitor want to visit, but there are many web pages that there are millions of visitors. Some applications have special requirement for high communication bandwidth and low latency. Okay, so some application needs more bandwidth for its working, and low latency means I had discussed the latency means the delay, low delay. It should have very low delay. If I am seeing a online video, so there should not be any delay. So example is multimedia apps. Wide range of system environment. In a distributed system, we have wide variety of software and hardware configuration. There are wide variety. Some uses Android, some uses Windows, some uses mobile phones, some uses desktop computers. So there is a wide range of system environment. That is, our distributed system must accommodate heterogeneous hardware, operating system, and network. Example, wireless network operate at a fraction of the capacity and much higher rates than present LAN. So there are some internal problems also, that are non-synchronized clocks. We cannot synchronize the clocks in a distributed computing system. Concurrency problems, many modes of hardware and software failures involving the individual components of the system. Means there can be a hardware or software failure, which can be an internal problem. Similarly, there can be external threats, that are attacks on data integrity, ensuring confidentiality, and denial of service. Denial of service means I am requesting a service from the server and the server is not able to respond me back. That is denial of service. So that were the some issues that designer of distributed computing systems have to face. Now I will discuss about the different design requirements for distributed architectures. So what are the design requirements? First is the performance issues. Means we try to maximize our performance. How can we maximize the performance of a system? So first will be responsiveness. How quickly our receiver can respond. So interactive apps require a fast and consistent response. Interactive apps, for example, online games. Online games require a fast and consistent response. There should not be any delay. The speed at which the response is obtained is determined not by just the server and network load and performance, but also by the delays in the software components involved. Means there should not be delay even in the software components. That is the operating system, the middleware services such as remote method invocation support like naming, and the application code itself providing the services. So system must be composed of relatively few software layers. If there are many software layers, then there will be more interaction and it can affect the delay, the message, the quick response that we want, and the amount of data transferred must be small. In the cases where a large amount of data needs to be transferred from the database, for example, performance will be better when the large amount of data is transferred over one database connection rather than connecting several times and each time transferring a portion of the data. Okay, so we need a dedicated database connection so that we can get a better performance when transferring a large amount of data. Next is the throughput. Throughput means the amount of services that can be processed by a receiver by the number of request it is being sent. So this is the rate at which the computational work is done. That is number of users serviced per second. How many users are being serviced? If there are 10 users and 99 users are being serviced, so the throughput is 90% and is affected by the processing speed and at the clients and server and by data transfer rates. So it is affected by the processing speed of the receiver, how fast it can process, and at the client, how fast the client can send its request, and by the data transfer rates. Next is the balancing computational loads. On a heavily loaded server, it is necessary to use several servers to host a single service and to offload work, example an applet in case of a web server to the client where feasible. Means what? When there is a heavy load, means a server is handling many requests, hundreds and thousands and lakhs of requests. So how can we minimize the workload of servers? We have discussed by distributing the workload with the help of an applet. Means the client installs an applet in its system and he gets the service from the applet itself. For example, on heavily loaded web service, that is search engines, large commercial sites, you can have several web servers running on the same domain name in the background and rely on the DNS lookup service to return one of the several host addresses for a single domain name. Means what happens if we want to search information on the net? Okay, so instead of dedicating a single server, we can have multiple replicated server, a local server which can handle that request. The next design requirement is the quality of service. So once the users have the functionality they need from a service, the next factor is the quality of the service being provided. This depends on the following non-functional property of the system: reliability, security, performance, and adaptability or extensibility to meet changing system requirements. So what type of service and how good the service is dependent on the reliability, the security, the performance, and adaptability. Means adaptability to different changes. If a process or system crashes, it should not affect the performance of the system. So the performance aspect of QoS was traditionally defined in terms of responsiveness and computational throughput, but for application handling time critical data, performance has been redefined in terms of the ability to meet timeliness guarantees. Yani what? Means in the terms of in real time. Real time means we are playing online games. We must get a fast response. If we are getting a fast response, it means we are getting a good service. In many cases, QoS refers to the ability of the system to meet such deadlines. Its achievement depends upon the availability of the necessary computing and network resources at the appropriate times. This includes being able to reserve critical resources. So we can also have the use of caching and replication. And web caching protocol, use of caching and replication. System often overcome performance problem by using data replication and caching. An example is web caching protocol used by HTTP to keep caches consistent. Means, for example, the example is cookies. In cookies, if we store our password, we need not log in again and again with using our email and password for logging into our system. So we can use the caching. Web caching protocol. Both browser and proxy server cache response to client request from the servers from the web server. Means both the browser and proxy server caches means stores the responses to client request from the web server. Thus, a client request may be satisfied by either a response cached by the browser or by a proxy server between the client and the web server. The cache consistency protocol needs to be ensured that the browser with fresh copies of the resources held by the web server. The protocol works as follows. The browser does not validate a cached response with the web browser web server to see whether the cached copy is still up to date if the cached copy is sufficiently fresh. Okay, it does not require again and again to see whether the copy it is fresh or not. Even though the web server knows when a resource is updated, it does not notify the browser and proxies with caches. To do that, the web server should need to keep a state, that is a record of interested browser and proxies, and HTTP is a stateless protocol. As you know that HTTP does not store anything. It is a stateless protocol. So what does a browser do? If it sees that a cache or the web proxy server needs to be updated, then only then it sends its updated copy. If it feels that it does not require to update, then it will not send the update copy. To enable the browser and proxy to determine whether the stored responses are stale, web server respond to a request by attaching the expiry time of the resource and the current time at the server to the response. So what does a web server do? It will attach a expiry time to every information so that if the information is expired, it will send a fresh copy of the information. Browser and proxies store the expiry time and server time together with the cached response. This enables a browser or proxy to calculate whether a cached response is likely to be stale. It does so by comparing the age of the response with the expiry time. The age of a response is the sum of the time the response has been cached and the server time. This calculation does not depend on the computer clocks on the web server and browsers or proxies agreeing with each other. If the response is stale, the browser validates the cached response with the web server. If it fails the test, the web server returns the fresh response, which is cached instead of the stale response. So, another design requirement is dependability issues and fault tolerance. Dependability issue. Dependability is a requirement in not only the mission critical application, example command and control activities like air traffic control system, but also in e-commerce application where the financial safety of the participant is involved. Dependability of computer system is defined as correctness, security, and fault tolerance. See, every application, every system is dependent on each other. So there should be a correctness, means we should trust each other that this system will always provide me the correct values. It should provide me security and it should be fault tolerant. Tolerant means even if it crashes, I should get my service. That is fault tolerance. So fault tolerance, depending dependable application should continue to function correctly in the presence of faults in the hardware, software, and networks. Reliability is achieved through redundancy. Redundancy is expensive and there are limits to the extent in which it can be employed. Hence, there are also limits to the guarantees of fault tolerance that can be achieved. For example, we have our mail account. Now, suppose the server in which our mail have been stored is crashed. Then what happens? Our mails are being stored in multiple servers. Our mails are stored in as a copies in multiple server. We have duplicate copies. So even if that server fails, even in that case also we can see our mails because another server handles those mails. So these systems are fault tolerant. At the architectural level, redundancy uses requires the use of multiple computers at which each process of the system can run and multiple communication paths through which the messages can be transmitted. Data and processes can be replicated whenever needed to provide the required level of fault tolerance. A common form of redundancy is having several copies of the data items at different computers, that is, replicating both an application server and the associated database server, so that as long as one of the computer is still running, the data items can also be accessed. Of course, replicating data involves incurring the cost of keeping the multiple replicas up to date. And last is the security. It needs to deal with the attacks on data integrity, ensuring confidentiality and denial of service.